Welcome to Homework Lib.
Given the function shown here, we are first asked to find the value of c such that this is a probability density function. A probability density function, when integrated from minus infinity to infinity, is equal to 1. So if we integrate this density function from minus infinity to infinity, it is 0 for x below 0. So therefore, we only have to integrate from 0 and above. And for x equal to 0 to 1, the density function is x. And for x at least 1 up to infinity, the density function is c over x to the exponent 3. This would be equal to 1. So now we just have to compute these integrals and solve for c. For the first term, we have 1/2 times x squared from 0 to 1. The second term, we'd have 1 over x to the exponent 2 times minus 1/2. And that's evaluated from 1 up to infinity. So the first term comes out to 1/2. And the second term zero minus 1/2. So that's 0 minus c over 2. And so we calculate c being equal to 1. For part B, we were asked for the mean of x. This is calculated by integrating the PDF from minus infinity to infinity of x times the function. So this time we're first integrating in the first term from 0 to 1 of x times x, so that's x squared. And then for the second term from 1 to infinity, c over x cubed times x is c over x squared. The first term, this is 1/3 times x to the exponent 3, evaluated from 0 to 1. And then for the second term, it's minus 1/3. I should be writing this as a 1 rather than a c, since we know c is equal to 1. So minus 1/3 times x to the minus 1. Minus x to the minus 1. That's what it should be. First term comes out to 1/3. And for the second term, we'd have 1 over infinity minus 1. So we end up with 1 plus 1/3, or 4/3. For part C, we're asked for the variance of x. Now we can use the shortcut formula for the variance. Calculate this as the integral of x squared times the density function minus the mean squared. So we're integrating from 0 to 1, x to the exponent 3. And then from 1 to infinity of 1 over x, and then we subtract 4/3 squared. So this is ln of the absolute value of x, evaluated from 1 to infinity. First term comes out to 1/4. If we take the natural logarithm of infinity, we get infinity. And so we'd say that this does not converge. And therefore the variance does not exist. For D, we want the probability that x is between 1/2 and 2. To find this, we integrate the density function from 1/2 up to 2. So we split it into two terms. We integrate from 1/2 to 1, x, and the second term from 1 to 2 of 1 over x to the exponent 3. And so we evaluate 1/2 times x squared from 1/2 to 1. And minus 1/2 times x times 1 over x squared from 1 to 2. For the first term, we have 1/2 minus 1/2 times 1/2 squared. I think I missed something there. We have 1/2 minus 1/2 times 1/2 squared. Well, maybe I had it right. Then for the second term, we have 1/2 minus 1 over 8. And this comes out to 3/4. And finally, for E, we want to find pi sub 0.82. That is the 82nd percentile. So that means that the probability of x being at most pi sub 0.82 is 0.82. This means that the integral from minus infinity up to pi of the density function is equal to 0.82. If we assume that pi sub 0.82 is greater than 1, then the first term we would integrate from 0 up to 1. And the second term would go from 1 up to pi sub 0.82. Just write it as pi. So we end up with 1 minus 1/2 times 1 over pi squared equal to 0.82. And so pi comes out to 5/3.